Okay, yeah, so yes. Good afternoon, everyone. So I'm last one. So I think I know all of you are tired. So I'm going to as fast as I can. So yeah, so my name is Hanhe, and then I'm from University of Dundee. Before my working in Dundee, I'm working in University of Constance. So I think today I'm very proud because 8 talks like use our data set called D10K, convey 1K, and then this kind of data set. And yeah, so, and yeah, today I'm going to talk about this, and also thank you for organizing this event. I think it's very interesting, and I would like to attend if you have next year. Yeah, so yeah, the topic, what I'm talking about is called the MMP2K. So it's benchmark multi-labeled macro photography image quality assessment database. So this is my undergraduate students' work. It's honor project, and but I think it's very decent. So I would like to share with you. It has published on ICIP, yeah, International Conference on Image Processing. So yeah, so macro photography, that means, and you can see there's examples from the data set. So it's capture object and a very extremely close range, and reviews very tiny details. And it has some kind of like say applications. I mean, while I was in Constance, I saw like biology. They have like a lot of photos like this one. Yeah, I mean, they want to get some details about that. So for research and also medical imaging. So, and it also has like highly sensitivity to these distortions. I mean, because you have to like take a very close, and then this object would be larger than the real life, right? So yeah, so in this case, kind of like say we will see most of this. I mean, most of this kind of like MP image is more like they have very clear foreground and very blurry background. So this came up a question. Okay, so is it? I mean, the BIQA, blind IQ method, that apply to the generic image, is it specific also for this MP images? We don't know, because we know that Conic 10K, we do some research, we found like Conic 10K that has a few images, but not all. So in this case, we said, okay, yeah, so this is kind of like, say we did some, so this is generic IQ, right? So it has different image, different perspective, different like the, this kind of like say contents. And the first was the live and TID 2013, that is kind of like artificially distorted image. And whereas this Conic 10K is kind of like it's called, I mean, live in the wild, I mean, it's kind of in the wild distortion, right? In the wild images. And we also did some research on this MP dataset. We found there's a kind of like there's only one paper, and it's published on very, I mean, not very prestigious journals. And what we found actually it has like, I mean, like you see here, they do, it's called, I mean, artificially distorted images. So they collect some like macro photography images, and then they apply this kind of like the different distortions artificially. So what we feel like the limitations is first, it is so it is a very small data set. It's limited content. So can I use this one? Okay. Anyway, so yeah, and another thing is kind of like there's a few distortion types, and we know that artificial distortion that is useful because whenever we use compression, right, this it's very helpful. But if we are doing in the wild, sometimes this is not enough. And also, whenever we apply artificial distortion, it will apply to the entire image. Whereas in the real world images, this distortion for this MP image would be the combination of different distortions. And so another thing is we found like there's no extra information that provide, and then so that's why we feel like because for these MP images, it's better to like have distortion annotated. Yeah. So here's an overview of this. So in this case, we collect like 2,000 macro photography images collected from the 3 websites publicly available, and we also labeled, because we call this is multi-labeled annotation. We have the MOS, meaning opinion scores, from the, cannot remember, so In total, supposed to be 23 participants, but after outlier removal, it would be 16, 17, something like that. And we also have some distortion types, severity, and also locations. So here's the examples of what we show here. We have the modes, and we also have description, because we feel like, because of language model, right? With that, this information that could improve the performance. And yeah, so this data set has been released on this kind of like say GitHub and then Hugging Face. Okay, so how about collect this source image? There's some more details. So first, we get from the 3 websites, Flickr and Unsplash and Pixabay. And because of IP issue, right, we also consider that they have the proper common CC copyright so that everyone can use, free to distribute it. And we also think about, okay, we have to get some machine tag or maybe just human annotated tags with the macro, kind of like macro information, okay, macro photography, this kind of like keywords. And then we download them, and we also did, because some of this image are not related to this content. Okay, so we also kind of manually filtering and also consider this kind of like low resolution. If the resolution is low, we don't want. We want to get like high quality, more or less. What that means, not high quality, high resolution. Okay, so yeah, so we also want to like have the uniform resolution, more or less unified, right? And then so we downscale them, and also yeah with the central cropping. And finally, we got this kind of like say around 50,000 images for pooling. Okay, so for sampling. And according to, yes, so this is how we do sampling. So according to my previous experience, we know that every data set, okay, this kind of like say quality assessment data set, you will find like there would be a picky. I mean, this is kind of very, it's biased, the data set we get, because most of this score would be between 3 and 4, right? So this is kind of like say good qualities. So in this case, I will say, okay, we want to keep the tail, both sides, low quality and high quality. And at the same time, we also found like these source images, most of these kind of like macro MP images, there are a lot of like the insects, and also like plants, flowers. So in this case, we say, okay, we also need to consider the content. And this is what we did. Okay, so we first using some objective matrix, of course, we use ours. So, and then we get this kind of like say distribution like this. And we also use the content, we get the content diversity. We extract the last layer about this kind of RiskNet 50, because that's about content, right? And then we do the clustering. We found like 2050, we want to sample like 2,000 images. So in this case, we set the K, the number of these centers is 2050, because we know that there would be some like outliers. Okay, so then we feed that into this kind of like the transaction on multimedia paper, and then to do sampling. And this is what we sampled. And you can see, of course, it's not perfect, but we get more kind of like say tailed images, right? High quality and low quality images. And yeah, so this is what we get. And then we also do some manually, so kind of like say filtering, and we achieve like this number we expected. Then we do subjective study. And for subjective study, it's lab study, but we also consider the reliability. And so in this case, first, we did a pilot study. We just use like, how many images? I cannot remember. Okay, 72 images. Okay, so we invited like participants which are more reliable in my team, 11 of them. And then we gave them like this instruction, and then gave them some examples we collected, and say, okay, now this is what you need to do. Give me some ratings, reliable ratings. And then we use that ratings. So after collecting these ratings, we also ask them like to say, okay, give me some feedback about this UI. Is it good? Should I improve so that you have better experience? And after that, we improve the UI, the ratings platform. We also use this 72 images as the test questions. We want to test if these participants are reliable. Okay, so then we have this main study. Okay, so it's larger, and then we have like instruction. We also give some training, and then we have this IQA experiment. But apart from that, we also have like 2 students like label this distortion, because we just feels like, okay, it's better to just have one annotation for this distortion rather than like multiple distortion, because then you have to reach agreement, which is very challenging. Okay, and yeah, so this is 2 of them, right? So IQA, actually, we just use ACR. It's very straightforward, and 5 points from the bad to excellent. And the annotation, we found like, okay, we found for this MP images, most of them, there are 5 types of the distortion. So out of focus, motion blur, noise, and artifacts, overexposure, and underexposure. Of course, we also allowed the participant to say, okay, give more ratings, okay, to kind of write down, okay, describe what kind of like say distortion which are not listed in these 5 types. And we also give some severity, mild, medium, and strong. And the 14 positions, entire image, left, right, up, top, down, and also top, left, very specific. Okay, so we get this kind of like say the ratings. After we get that, we also do some outlier removal. So we first consider this test question. That's what I mentioned that, okay, I have like 72 images, right? We have that ratings. And then we say, okay, they must be like, okay, within that range, okay, past that, if it's accurate. For example, okay, if this MOS is 3, we will say, okay, between 2 and 4, that should be correct. If it's out, then you are not reliable for some reason, okay? And we also think about the consistency with the majority. So we have the MOS. We have the rating for each participant. We compare this correlation, PLCC, between like a majority and then each participant. So if the correlation is very low, we also exclude. So eventually, we get 17 participants out of 21 participants just for MOS. Okay, this is just for MOS. It's not about this distortion annotation. And yeah, and you can see still like this is quite like same like what we have for most of the data set. It will have like a lot of more or less okay-ish quality, I mean stimuli, right? And then we also generate the quality report. So as I showed before, okay, so we have a template. So the image is what in quality. And then we have like, we just arrange them. I know this is not a very kind of like say, there might be some issues about this range, but this is what we did. And distortion annotation, we have like there's B, C in the D. Okay, so B, that is distortion magnitude, and then distortion type. C, D corresponds to the position. And for this one, and you can see that is the quality is very low, and then this image is fair in quality, and then there will be a strong out of focus, this part. And also the entire image, that will be mild under exposure. It's to be brighter a little bit, right? So yeah, so once we have this, we also want to check our hypothesis. Okay, the generic blind IQA, how does it work? So this is what we did. We just using the pre-trained model, the state-of-art blind IQA model, and test on this kind of like our data set. And you can see the best one, which is top IQ. It's just 0.80. That is not very high. And it actually is in live, and also this Connect 10K, it's very high because I think someone mentioned that it's transformer based, right? It has supposed to have very kind of like say the good performance, yeah. So yeah, so this is our observation. So BIQM method showed much worse performance on MP images, and the existing SOTA by IQM method designed for the generic nature image are not suitable for MP images. So in this case, like we also fine-tuning it, and after fine-tuning, it improves. like from the top IQ, it's from 0.8 to 0.83, right? Something like that. So it indeed improved, but it's still not that significant. Could be improved further. So in this case, the student, not me, so the student say, okay, maybe we can try to improve based on the best model, which is top IQ. And so this is top IQs like the architecture. And the student say, okay, now I have the informations about this distortion type, distortion positions. Then he encoded in this way. I'm not going to talk about details because I think my time is already, yes, I only have like a few more minutes. And then, yeah, so this is how they did, like encoded. And the performance improves. So, and you can see it's this already achieve like, improve like 5%, let's say 0.05. And here's some example as result. So on the left is ground truth, on the right is prediction. So yeah, so here, this is kind of like heat map, and you can see, so it will, this kind of like say highlight is center right, mild under overexposure, and mild out of this focus. Yeah. So if you ask like, what is this? Yes, so because we only have the position, right? 9 different regions. So that's why we kind of like say we use that to predict the magnitude of the distortion. Yeah, we kind of like say changing to some format. Yeah, same like this one. So, and yeah, so this is kind of like the image in good quality. And this is our predicted result. And we also see like this is here highlight. There might be some like out of focus in the center. Yeah. And this one. So yeah, it's fair in quality. And this is not a very good example. And you can see some this we want to, the idea is we want to maybe focus on here, but you can see the model is focused on this part. So that's why it has like, poor performance. Yeah. Okay, so I should have talked about more details because I feel like I still have time, right? So yeah. So anyway, so this kind of, you can ask me questions because I'm happy to answer. So, and yeah, so this is AI generated like the conclusion. So we established this kind of like say the data set. It's the first large scale real world like multi-labeled, the photography, macro photography IQA data set. And we're also conducting this reliable subjective quality assessment and the multi-labeled annotations. We also ensure like this procedure is, kind of like say, strict so that we can get a very good performance. The reliable ratings, let's say. And we also demonstrating this kind of limitation of this existing BIQA models on macro photography images. And it is also showing fine-tuning, improve indeed. And but if we have some more using this extra information, we can also like say improve this, enhance this distortion. The IQA on this like micro photography images. Yeah. So thank you. And any questions?
So Netflix has this serial software for scaling mean opinion scores. I assume that you didn't do any extra scaling beyond kind of averaging the scores. So what do you think about kind of those psychophysical scaling procedures that try to assess reliability and other factors related to each labeler?
Yeah, I think that's a very good question. I think you also did some work, right? It's whenever we use ACR is very fast. This is very kind of I say, okay, it's easy to get the ratings, and it's very cheap if we conduct like the crowdsourcing. But whenever we use pair comparison, like we can randomly sample the active learning or this kind of thing. And in that case, like but still, it's very expensive somehow.
Yeah, maybe to specify. No, I'm not saying that pairwise comparison could be better. Serial also can scale mean opinion scores. So you can get your mean opinion scores, send it to the software, and they will essentially try to, for example, find less reliable observers and weight them less, and so on.
Okay,
So they have Bayesian model.
Okay. I didn't try that because in this case it's a lab study. I feel like we just want to maybe filter out some of them, like it's more like they are tired. They have fatigue. They do because they do some work. But yes, that's a good suggestion. If I do like
trying and seeing the difference between kind of regular mean opinion scores and after processing, just to see whether there's any benefit of performing such scaling.
Okay, yeah. That's a good suggestion. I will try that. Yeah.
Yeah. I'll ask you a question.
Yes.
So for, I think, all deep learning based models, the first layer is to aggressively downsample, right?
Yes.
So we get rid of all of the fine-grained features in the first pass. Obviously, for this macro imaging, even when we do that, we've still got very fine-grained features. We've got eyes, we've got fur, we've got like very fine-grained textures. So do you think because of that we need to rethink the model architectures that we're using to focus more on those fine-grained features than our other models, which are probably focusing more on low-frequency components?
I never thought about that, and we did something about the like face. That's what we tried. I mean, so for our previous work about the face IQA. So if we're fine-tuning on some models, for example, ideally for this generic image, they will only focus on for face. Only focus on like background or something activation. But with fine tuning, then all of this kind of like activation will focus on the here and here, nose and mouth, something like that. So yes, in this case, maybe you're right. I mean, I haven't tried this, but I feel like if we only focus on this foreground, background, like something like that, that might be improved. But I suggested student, but student didn't try that. And yes. That's kind of like the things we can try. Yeah.
Anyone else? Okay, thanks, speaker.
Yeah, thank you.
Okay, just to say that that's the end. We've had some really great speakers today. I hope you've all enjoyed it. I hope you've met some really awesome people in the same field, and I hope you'll have a safe journey home. And if there's enough interest, then maybe we will run another one in a year or so's time. Thank you, everyone.
Oh, sorry.
I forgot to thank you again. I did thank you.